morning. I am Dr. Nalini Vaidya from Department of Applied Mathematics, GH Raisoni College of Engineering, Nagpur. Today, I am going to introduce Laplace transformation. First of all, we see what is the Laplace transformation and what are the applications of Laplace transformation. So, why we need to study the Laplace transformation? After studying the Laplace transformation, we can easily find out the solution of differential equation, then partial differential equations easily while doing the classical methods of solving differential equation and partial differential equations. There we need to find out the complementary function and then particular integral, then we have to find out the general solution, and then after that we have to find out the arbitrary constant. Laplace transform helps to find the solution easily without finding out the general solution, and its application to various engineering as there are in mechanical heat conduction equation and the wave equation. So, we can solve that equations easily by using the Laplace transformation. Then in electrical engineering, we can convert the wave from the differential equation by using the Kirchhoff's law, and that differential equation we have to use the Laplace transformation to find out the solution easily. Also in civil engineering, we can find out the solution of the deflection of beam. There we have to convert that the process into the partial differential equation, and then we need the Laplace transform to find out the solution easily. Now, actually what is Laplace transform and what its requirement? So, while studying the Laplace transformation, we need function must be the piecewise continuous or continuous function, and then secondly it must be of exponential order. Now, what is Laplace transformation? So, here suppose here the function is f of t and here the domain is f bar of s. So, here it is the t domain and here s domain. So, Laplace transform converts that ft to f bar of s, and the definition of Laplace transform is L of f of t is equal to from 0 to infinity e power minus st f of t dt. So, this RHS, that is 0 to infinity e power minus st f t dt, it is the improper integral, and Laplace transformation exists means that right hand side must take some finite value. Then here one more application of the Laplace transform is we can find out the solution of easily the definite integral, which cannot be possible while the integration by parts and all that. In that procedure that becomes very lengthy, but while using the simple basic formulas of Laplace transform, we can find out we can solve the definite integral easily, such as we need here, suppose I will take the example, if we know L of 1. So, how to find out the L of 1? It is very easy. We have to apply the definition here itself. So, here f t, what is f t here? 1. So, it is 0 to infinity e power minus s t and f t is 1 dt. So, here we can solve it, that is e power minus s t only. So, here the integration is e power minus s t and it is with respect to t. So, divided by what it will be? Minus s, and this is here 0 to infinity, or it is minus 1 by s into e power minus s t, and the limits are 0 to infinity. So, minus 1 by s here e power minus infinity minus e power 0. So that is minus 1 by s, and we know that e power minus infinity is what? 1 by e to the power infinity, and 1 by e power infinity is 1 upon infinity, and 1 upon infinity is 0. Okay. So that value of e power minus infinity is 0. 0 minus 1 is equal to minus 1 by s, and minus 1 is 1 by s, and it is easy to remember to find out the L of 1, that is L of 1 is 1 by s. We need, just like d by dx sin x is cos x, here L of 1 is 1 by s. So in this way we can find some basic formula, that is just like Laplace transform of e power at. So here also we can use the definition e power instead of ft. Here we can put e power at, then we can take the here power, and we can find out here 1 upon s minus a is the solution, such as number 3, e power e minus at is also 1 upon s plus a. Okay. So these are some basic requirements while studying the Laplace transformation, and these are the basic formulas, such as we can also find L of t power n is. Okay. So instead of putting that f of t, we can put whatever is in the bracket L of e power at, L of e power minus at, t power n, and we can solve the integration. So in this way, if we have the list of the formulas of Laplace transformation, that the primary formulas, then we can calculate the differential equation, we can solve the differential equation easily using this formula, and there is another method. Okay. Now here we can find out Laplace transform of t power n is gamma of n plus 1 upon s power n plus 1. So how to find out this? We can use here to solve this integration, we can use the gamma integral. Now I will give one example how easily we can solve the integration using Laplace transform. Suppose we have to find the integration of 0 to infinity e to the power minus 2t and sine cube t dt. Okay. Now this integration, if we can solve in general way, that is by integration by parts, it will take more time and more pages also required. Okay. Now here we can use the Laplace transform method. So this can be written as, just see, this is sine cube t dt and e power minus st. So we can compare this integral with the definition itself. Here 2, it means s is equal to 2, and what is ft? Ft is equal to sine cube t. Okay. So that we can write it as, it is nothing but Laplace transform of sine cube t at s is equal to 2. Okay. Now this we can have the basic formula. So Laplace transform of sine of at. Sine of at is here a upon s square plus a square, then Laplace transform of cos at is equal to also s upon s square plus a square. Now here sine cube t. So we have to first convert that sine cube t in the form of sin at or cos at. So we know the formula L of 3 sin t minus sin 3t divided by 4 at s is equal to 2. So this is nothing but 1 by 4 into Laplace transform of 3 into sin of t and minus Laplace transform of sin 3t. Okay. Now here we know the standard formula of Laplace transform. So 3 into, what is sin t? Here sin at is equal to a upon a square plus a square. What is a here? A is equal to 1. So we can have 1 upon s square plus 1 minus, now here sin at, a means 3 here, so that is 3 upon s square plus 9, that is a square. Okay. Now at s is equal to 2, so we can find out here 1 by 4 into 3 by s is equal to 2 means here 4 plus 1 minus 3 upon 4 plus 9, and that gives you 1 by 4 times 3 by 5 minus 3 by 13, and rest of the thing you can calculate the latter. So you can see how quickly you can find out this integral value using the Laplace transformation. Thank you.